260 DC motor. This is 260 DC motor. Already have the pin installed, and we're going to have a test load. Let us connect the jumper to test the DC motor. Then we supply the voltage. We're going to supply voltage, adjust. This is adjustable power supply. It starts at 150 volts, 42 ampere, about 5 volts. At 5 volts, we have 0.068 ampere, 0.348 watts. Voltage at no load 5.05 ampere, or the current at no load 0.069 ampere or 69 milliampere with a power of 0.348 watts. How about let us again how about stall current? Stall current when the motor is jam, or stall current, jam current 0.8, 0.825 ampere or 825 milliampere. And then we're going to use this fan blade 4-lip as a load. Now our DC motor now is an electric fan. It is a fan, face fan, yellow blade, supplying at 5 volts. So at 5 volts, 255 milliampere or 0.259 ampere. And then the wattage now is 1.3 watts. That is now the ratings of our motor. It can work on 5 volts. We have now our circuit. This is our fan, electric fan, and then connected to our circuit. This is the circuit using the potentiometer. This one is an input LED, some resistors, and then the transistor. So we're using transistor, power LED, then the diode. This is speed control. We're going to control the speed of this fan. Let us put it in here. Just to see. Put some tape. Okay, then we're going to use our adjustable power supply. 5 volts, adjust to 5 volts. So at 5 volts, when I rotate the potentiometer counter clockwise to the left, slowly, so our LED turns on. That is the input LED, monitor LED. It means our fan now is working, running. Slow. Slow. Fast. So we can have this phase fan or electric fan. We can use this. And then our current use is at full speed, 0.254 ampere. 0.254 ampere or 254 milliampere with a power consumption of 1.294 watts. While without so we can adjust slowly the current. We can decrease the current. 47, 39, 26, 19, and then up to 0 again. When I turn on this 11, 12, 13 milliampere, 17, starts moving at 155 milliampere. Our fan, 0.769 watts. Then we can adjust up to 254 milliampere or 0.254 ampere. So we have now the LED. As we are decreasing the speed, LED slowly turning off. Then it is fully turned off. So you can see the LED is increasing, decreasing the light once we adjust the potentiometer to the left and to the right. So we have now a speed control using transistor. We now have this figure 1 fan speed controller using transistor. So where is the fan? This DC motor, positive, negative, M symbol, connected to the collector of our transistor D882 power transistor. We use this transistor as a switch collector base emitter. It can able to handle up to 1 ampere, at least 1 ampere of current. And in our demo, in our test load, we are only using approximately 300 milliamps or 0.3 ampere. So it is safe to use this transistor. 0.3 ampere, while our transistor from collector to emitter, we can pass a current here for about 1 ampere. Also in our circuit, we have this green LED. So whenever we rotate, adjust the potentiometer, 100K potentiometer, this is the adjustment, 1, 2, 3 pin. This is potentiometer, 1, 2, 3. So 3 is here, 2, 1. 2 is the middle, that is the wiper. It moves. When we rotate it to the right, if this is the potentiometer rotating to the right, it means the initial setup is from here, then up. So it will now connect to the pin 1, then 2, then R2, R3. So this is the output LED, or the input or output, should I say output, with 180 ohms resistor in series as a current limiter to the green LED. And then to the collector, we have this diode 1N4007. What is the use? Clamp diode to protect the circuit from back EMF. Because of this motor, it could create an induced voltage to the circuit. So because of the diode, it will just compensate with the current and voltage produced by this DC motor. It can counteract the back EMF produced by this DC motor. All in all the trees are connected to the 5 volts power bank. So our potentiometer here, when we rotate it to the left counterclockwise, it means our wiper, the initial is from pin 3, then moving upward. This will connect it. This will make this potentiometer to connect to the R2 and R3. R3 to the base of the DA2. And then we have this power LED monitoring the power. If we connect the 5 volts, we have now the power LED. This power LED turns on 4.7 current limiting resistor. Why is it that the motor is we can able to control the speed of the motor? Initially, it is positioned here. The wiper connected to the R2, R3 here. So it is positioned here. There is no current that flows into the R2, R3. Because we need the current here at the base to turn on, to switch on this transistor. Current and the voltage of 0.7 volts, at least 0.7 volts for the transistor. It could be 0.7 volts or 0.6 volts. So when we switching on this transistor base to emitter, there's a current and a voltage. We can now turn on this DC motor, and then this LED. Current flows here to the collector, then collector to emitter, then to the ground. So the purpose of this transistor is as a switch. So this collector emitter will switching on will saturate, or switching on almost act as a short switch once there is a voltage here. So initially, if the wiper is here, the current flows into the R1, 100K, then to the wiper. Initially, this one is connected here, and then to the R2, R3. There is no current into almost a small amount of current to the base R3, 1K to the base, which is not enough to turn on this transistor, because all the current flows will consume by this 100K resistor, because initially our wiper pin number 2 is located at pin number 3, somewhere here. Due to the large amount of resistance, this DC motor still not running. It will not run our DC motor, and then green LED will also turn off. Once we adjust the potentiometer here, moving the wiper upward and then up to here, so it becomes now current flows from BCC, then pin 1, then shorting it to shortcut to the R2 and R3, because our wiper now is located here, pin 1. So the current now flows from R2, R3. The current flows division of current here from R to R3, and that current is enough to turn on this transistor to produce at least 0.7 volts to the base and emitter voltage. It will turn on the transistor, so LED now turns on. Also the DC motor will run. DC motor is running because this collector meter now is act as a short switch or shorted switch or saturated collector to emitter, then to the ground. Current flows from collector to emitter, then to the ground. So we can move or rotate this wiper or this potentiometer up and down. In that case, or in that moment, or from that moment, we can now increase or decrease the light of the LED and the speed of the DC motor. So we have now that is now our circuit, how to control the speed of the fan or the DC motor, which is the fan. That is the DC motor fan, speed control. Controlling the speed of fan using this D882 power transistor.